So let's say you have an ice cream shop and you have 10 flavors at your ice cream shop, and you want to know how many unique flavor combinations can I make with the 10 flavors in a 2-scoop cone. So the first thing that you're going to want to have to do is understand the fact that after every sort of stage of flavors, like if you go with your base flavor, say here we have vanilla and then we go chocolate, you're going to lose a combination because we're talking unique combinations here. Or vanilla chocolate comes up, obviously, but then you can't go chocolate vanilla. That's the same thing. So you end up losing a combination there, right? And so what that means is that you go 10 plus 9 plus 8, you add 10 plus 9 plus 8 plus 7 plus 6, as you know, as you can see here, to get your amount of unique combinations, which is 55. And way to find 55, there's two ways to find 55 that you can do without just brute forcing it, because if you want to solve for n flavors and you have like 300 flavors, brute forcing it, just adding, is not going to work. So the first way that you can do it is this way that I kind of devised and came up with on my own, just kind of thinking about things. I went amount of flavors that you have times the amount of total combinations initially, right? So 10. Or you can just go flavors times flavors, it's 10 no matter what you do. So you do 10 times 10 minus the sum of the lost combinations. And that's where I kind of got stuck, because the lost combinations here, it's easy, you can go 9 plus 8 plus 7, but you can't do that with like 300 flavors. Again, it's going to be really hard. So what I did is I got some data points of the amount of the sums of the different lost combinations that you have with different starting flavor amounts: 10, 45, 7, 21, 5, 10, yada yada yada. So I plugged those in to mycurvefit.com, which gave me the equation for that graph, which looked like this. It's real messy, I'm not going to talk about it. And that, with x being the amount of flavors that you have, you plug that in, but you get 45 through doing all this, minus 100 gets you 55. That works out real nice. But the other way you can do it, which is a lot nicer, is triangular numbers, which I have down here. With triangular numbers, the way the formula works, n times n plus 1, is you do your triangle. Say we're doing just 6 here, just keeping it real nice. You have your triangle of 6 points, and you add a second triangle of 6 points, and then you get a nice little square here that's 12 points, or rectangle that's 12 points, all in total. Base of 3, height of 4. But you're dividing it by 2, right? So you have your base n times n plus 1, because this is 4, divided by 2, and that's how you get the area of a triangle. So in this case, it would be 10 times 11 divided by 2 is 55. And that's probably the best way to go about solving this, just because it's the nicest. So for the extension part of this project, I decided to add a third scoop. And the third scoop was actually really freaking complicated, because just for 3 flavors, it's everything that's up here. So I did every combination possible with chocolate, every combination possible with vanilla and no chocolate, and then just every possible combination with strawberry. And I got 10 flavors, 10 combinations with only 3 flavors. And when I had 2 flavors, I got 4. And so I don't really know the best way to go about solving my extension just yet, because it's obviously exponential, it's obviously a curved line of some sort, but I don't really know what it is. So perhaps as the year progresses and maybe I'll learn more about slope and finding curved lines. I don't really know what we're going to be doing yet. Obviously, I'm not the teacher, you're the teacher. I will be able to perhaps figure out the best way to go about solving this problem with the curved line and the exponential that it is right now, but unfortunately at this point I do not know the best way to go about solving this extension.